Pour a glass of milk, cold, white, every protein molecule identical to what came from a dairy farm. Now consider this. The cheese sitting in most supermarket refrigerators right now already contains an ingredient produced without any animal involvement whatsoever. Most people eating it have no idea. Microbes are making milk proteins, not approximations, not plant-based stand-ins. The actual casein and whey, the two proteins that make milk what it is, built inside fermentation tanks by genetically engineered organisms that have been given one job: produce the proteins a cow's mammary glands would otherwise make. This is called precision fermentation. The microbes ferment, they produce the proteins, and those proteins are combined with water, fats, and sugars to create something molecularly indistinguishable from conventional dairy. The cow is simply absent from the supply chain. To understand why this matters, you have to understand what every plant-based milk has failed to solve. Oat milk doesn't contain casein, almond milk doesn't contain whey. Those products replace dairy's function in a recipe while delivering a completely different molecular profile. That's why plant-based cheese doesn't melt the same way. It's why plant-based yogurt has a different texture. The proteins are missing. Precision fermentation doesn't replace the proteins, it produces them. And here's the detail that reframes the entire conversation. This technology has already been operating quietly inside the dairy industry for years. Traditional rennet, the enzyme used to coagulate milk when making cheese, historically came from the stomach lining of calves. The industry needed an alternative that worked at scale. Precision fermentation delivered one. The enzyme it produces is functionally identical to the animal-derived version. Most consumers eating vegetarian cheese have been eating a precision fermentation product without ever knowing it. That's not a footnote. That's proof of concept, running at commercial scale inside an industry that still markets itself as entirely traditional. A company called Remilk is now applying that same logic to the proteins themselves, not just a single enzyme, but casein and whey, the full foundation of dairy. What Remilk produces isn't a dairy alternative in the traditional sense. It's animal-free dairy, the same proteins built through microbial fermentation with no cow at any stage of production. The implications stretch well beyond a glass of milk. Casein and whey are foundational to yogurt, cheese, butter, ice cream, infant formula, and protein supplements. Every one of those categories becomes accessible to this technology once the proteins are reliably producible at scale. Infant formula is worth pausing on. For families who cannot access breast milk, formula is non-negotiable. Precision fermentation offers a pathway to formula containing the actual proteins, not plant-derived approximations, produced without animal agriculture. Researchers and food scientists have identified this as one of the most significant potential applications of the technology. There's also an allergen dimension. Many people sensitive to conventional dairy react not to the proteins themselves, but to other components of animal milk. Animal-free dairy can, in principle, be designed to contain only the proteins, without the specific compounds that trigger reactions in sensitive individuals. Dairy farming is resource-intensive in ways that are becoming harder to ignore: land use, water consumption, methane emissions from herds. Precision fermentation sidesteps those pressures entirely. The microbes work in controlled fermentation tanks. They don't need pasture. They produce proteins on demand. The open questions are real. Scale is the central challenge. Producing casein and whey at the volume needed to supply even a fraction of global dairy demand requires industrial infrastructure that is still being built. Cost follows scale. As fermentation capacity expands, costs are expected to fall, but price parity with conventional dairy remains an active area of work. And consumer acceptance of the phrase genetically engineered microorganisms will require its own period of normalization. None of that dismisses the technology. It's the normal friction of any significant food system invention moving from laboratory proof to supermarket shelf. The vegetarian rennet already inside most supermarket cheese is the clearest signal of where this is heading. That ingredient, molecularly identical to its animal-derived predecessor, has been in the food supply for years without disruption, without controversy, and without most consumers ever noticing the difference. Raymilk and the companies building animal-free casein and whey are following the same path at a larger scale toward a larger set of products. The science already works. What remains is an engineering and scaling problem, and those tend to get solved faster than anyone expects. Subscribe for more stories like this. and read the full article at factstormhub.com.